another international speaker that, of course, is very complicated to present about his movement in his life. I can introduce him, first of all. Ian Chui. Is right the name, the pronounce? Okay, a big applause to him. Just to say, he is Chinese, but moved to England at 15 and now lives in Amsterdam. He is a great helper of companies to move to other kind of cloud structures and so on, and he will speak about this. Right. Nice talk here, Ian.
All right, okay. Thank you, everyone, for joining us this afternoon. Oh. Thank you very much. So yeah, my name is Yan. I've been building stuff on AWS since 2010. So I went through the whole journey of EC2, containers, and serverless. And nowadays, I spend half my time working with Lumigo, which is, in my opinion, the best observability platform for serverless and also for container workloads as well. The other half of my time, I spend helping other companies adopt serverless. And a big part of that is how do you create a workflow that makes you developers work with, let's say, serverless services like Lambda more efficiently. And I kind of narrow it down to maybe 3 main categories in terms of what you need to be able to efficiently develop serverless architectures. You want to make sure that you know how to test your application. You want to figure out how to make sure your deployments are easy and hopefully less friction, but also how do you manage your application development environment as well. So starting with testing, I'm a big fan of testing locally and having that fast feedback loop of able to make a code change and straight away test it without having to wait a couple of minutes for deployment to the cloud. So a big part of what I've been working on the last couple of years with customers is how do you get that fast feedback loop when you're working with cloud-based services. And there's a very common thing that comes up that people come to me and say, yeah, but when it comes to like Lambda and serverless, there's just no local development approaches. And I'm going to show you 5 different ways that you can actually achieve different way of local development experience. And many of them are things that you probably are familiar with already. One of the options is to looking at the hexagonal architectures, which is an architectural pattern that sort of structures your application components in a way that can easily fit into different execution environments by introducing abstraction layers, what we call ports and adapters, which is why hexagonal architectures is often referred to as ports and adapters architecture as well. And you've probably seen this before, that is presented into this like a hexagonal shape, where in the middle, you've got your core domain logic. Those are your business logic that basically differentiates what you do with other companies. And then it's hosted inside your application layer. And your application code needs to just can't exist on its own, right? It needs to talk to the outside world, to get data, to write data, publish events, or what have you. And so that's where you introduce ports. And those ports are then connected to the outside world through adapters. So in this case, you've got your core business domain logic, and say you want to trigger this logic when some user makes an API call to your service. So you can use one of the adapters and write a client application that is, say, a Lambda function. And what this adapter is going to do is it's going to take Lambda's invocation event. And for those of you who are familiar with AWS Lambda, you are probably familiar with the fact that a Lambda function is always invoked with an event payload and some context object. But that doesn't mean anything to your domain. So your adapter is going to take that invocation event and then turn it into something that your domain understands, like a command to create a user in your system. But tomorrow you may decide, OK, Lambda is no longer the right fit for us in terms of my compute layer, and so I want to move my application to, say, running on containers. Well, fine. I can just write another adapter that adapts my core domain to an environment that's, say, an Express.js application or Fastly application running inside a container, in this case, Fargate, for example. So hexagonal architectures gives you a lot of portability that allows you to, say, take the same core domain, but then run it as part of, say, a Lambda function, or maybe as part of a container application as well. So this makes it easy for you to, say, later on change your mind, or as your business requirements change. Maybe Lambda and API gateway is really cost efficient when you're doing 5 requests a second, but less so when you're doing 5,000 requests per second, at which point it's much more cost efficient to run it on, say, containers with, say, ALB in front of it. So you don't want to spend a lot of time rewriting the entire application when that happens. And hexagon architectures give you that portability later on when you need it through those abstraction layers that you have provided. Equally, when the whole domain wants to reach out to the outside world and get some data or to publish events or what have you, I can have adapters that connect it to external ports to, say, write data or to read data from DynamoDB. But that doesn't really help me when I want to do local development. I'm not going to run, well, I could, but I'm not going to, say, want to run DynamoDB locally. So in that case, I can have an adapter that talks to a mock so that I can easily write unit tests that I can quickly execute, run, and find bugs before I have to deploy and wait for that whole deployment time. Or maybe tomorrow we realize, well, we started with DynamoDB. It was fine when we were all just basic CRUD. But our basic domain has evolved. There's much more relationships. So we want to move to, say, RDS, so we can run relational database instead. So I just changed the adapter. My core domain remains untouched, but the adapter allows my core domain to now talk to a relational database instead. And so these hexagon architectures allows you to plug and play different parts of application and slot them into different execution environments. And so it's give you that nice portability. And because it's just basically a way to structure application, create abstraction layers, so it's universally applicable to any language you want to use or any deployment framework. You're not limited by the fact that you're using CDK or Terraform or what have you. But then again, when we talk about serverless, we are not just talking about Lambda functions. In fact, a big part of the serverless movement is about how do we move away from focusing and running technology to creating value for the business. And oftentimes, the best way to create value is to use managed services that don't make me have to think about how many servers do I need and how to patch them and whatnot. And also importantly, I want services that can scale to 0. So when there's no traffic, I don't pay anything for it. And ideally, I'll get usage-based pricing so that when people use my application, I pay for individual requests as opposed to for uptime based on how many nodes I need to run and so on. So any services that meet this criteria is considered serverless in my mind. So things like AWS, Amazon S3 or DynamoDB, all of those services meet these criteria, and they are serverless in my mind. And there's a good adage when we first started the whole serverless movement that, well, Lambda function is a useful tool, but you should have Lambda functions where you have some business logic to transform data. You don't want to write custom code just to take some data from one place to another without any transformation. In this case, if I want to have a REST API that, say, I can have API gateway to be the host of my API, and for authentication, I can have API gateway do authentication through Amazon Cognito. And I don't have to write Lambda functions to just write something to a database. I can have API gateway do that for me. We'll see some examples later. And if I say, OK, I want to turn those database events like role inserted into a domain event, say user created, I can do that with event bridge pipes connecting the DynamoDB table to an event bus. And I can use Lambda function in the event bridge pipes to then do the transformation to turn it from a data inserted event, which is a database event, into a domain event about user being created and whatnot. I can also have event bridge pipes to turn those events and use them to call third-party APIs and do other integrations. So there's a whole world of managed integrations I can do using just services with a few lines of configuration. And in this case, well, if my whole approach to testing is just going to be focused around what's in my code, I'm not going to be able to touch and test those managed integrations anymore. And so in this case, I also have to think about, OK, ahead of time, what abstractions do I need? What ports do I need? So there's a bit of upfront work you need to invest into your code as well. And those are some of the downsides in terms of hexagon architectures. And that kind of brings us to using local simulators. And right now, the biggest one in the market is a local stack, which allows you to say, take my whole serverless architecture without any custom Lambda functions and just run it locally, simulating all the different services and how they integrate with each other using local stack. And one of the nice things they have introduced with LocalStack version 3 is that they now have ability for you to enforce IAM rules so that if you got some IAM permission issue between event bridge pipes and event bridge event bus, you can see that error in your local console in LocalStack, so you can quickly debug those. Anyone who has used those integrations in the AWS would know that sometimes those IAM permissions are really difficult to debug. With a LocalStack, that becomes a lot easier. And again, if I do need to write, say, a Lambda function to do some transformation of those events, I can still do that, and I can still use LocalStack to simulate those code, and I can put breakpoints in my code and walk through them when there's a problem in my Lambda function, for example. So the nice thing about using local simulators is that, in terms of local development, is that you're not limited to just Lambda, not just your code anymore. You can simulate entire architectures, but it's still a simulation. It's never going to be 100% the same as the real thing. You often find that there are missing API support, or it just behaves slightly different to the real thing, especially when it comes to, say, some of the edge cases you may run into with some of these services. OK, so in that case, what about if we just take how we do things right now, building Express applications or whatever framework you want to use, and just run it inside a Lambda function? So instead of having API gateway doing routing to different functions, I'm just going to have one route that routes everything to one Lambda function that is running a web application inside it. There are actually quite good tooling support for this approach nowadays. You've got the AWS Lambda web adapter, which essentially sits in front of your actual your code and converts Lambda's invocation event to your framework so that you can just run Express inside Lambda. There's also more specialized frameworks like Serverless Express. You've got Breath, you've got Zapper for different languages, and so on. And the nice thing about this approach, again, is that portability. You can, tomorrow, you change your mind, you want to go from Lambda to containers, just take your Express app and run it inside a container. There's not much code change you need to do. Equally, this approach is very familiar to developers today already in terms of how you write code, how you test them, how you simulate, say, SQL with SQLite locally and all of that. So that nice familiarity is going to make it a lot easier for your developers to start adopting serverless and Lambda, for example. But once again, it's just looking at your code. If you're using serverless in terms of managed integrations, you can't test those because, again, this approach is just looking at what's going on inside your code. And a lot of frameworks that we're talking about, like Express and whatnot, they're also not designed with Lambda's constrained execution environment in mind. And oftentimes, they're quite big and bulky, and that has a big impact in terms of the code start time for your Lambda functions. That's another thing to consider as well. Also, when we're talking about serverless architectures, it's not just all APIs. There's a lot of event-driven architectures going on. There's a lot of data processing and whatnot. Those doesn't quite fit as nicely in terms of tooling and ecosystem compared to building Lambda lifts for APIs. And lastly, when you have one function that handles all the routes, you have less fine-grained control in terms of metrics, as well as being able to use different access control mechanisms. What if one endpoint is want to use IAM for authentication and authorization, but another one needs to authenticate users against JWT tokens and whatnot? It becomes harder for you to have that fine-grained control in terms of different routes. And you can make up for that, but that's something that you have to build into your own application as opposed to just leverage what like API Gateway gives you out of the box. Well, OK, so what about if we just use some of the frameworks that's out there? Things like SST has got the SST dev command that allows you to invoke a Lambda function remotely, but still get breakpoints and get that breakpoint information coming all the way down to your IDE so you can step through the code and figure out what happened, what went wrong. SAM has got a similar thing. Server Framework's got a similar thing as well. Lots of frameworks provide this kind of tooling and support for you for debugging things locally. So that's great. So the framework is doing all the work. There's not much for you to do, except now, if you want to use a different framework or go to a different company that uses a different framework, then, well, I lose that ability to do the local development and breakpoints and all of that stuff that the framework I was using before gave me. And also, again, what happens when I want to use managed integrations between different services? This, again, doesn't really help me with that. So And one more thing I want to mention about this is that a lot of the time, when I want to, say, work on a new Lambda function, some new code I want to deploy, it's really nice to be able to run SST dev to start working through it, figure out problems before I deploy. But those are still more what I call exploratory tests. They don't replace your automated tests. And if I want to say, make some changes, I want to make sure that I haven't broken anything, I'm not going to run SST dev and execute every single code path myself. That would be ridiculous. So I still need to have automated tests that can catch any regressions that may happen. So even if you do all of this, you still need to figure out how do I write tests for my application so I have some confidence that it's actually working. And that brings me to the last option, and one that I probably use the most often, is what I call remote code testing. So this is basically taking the idea of local testing, running your code locally, and combine that with executing it against remote resources that are running in AWS. So essentially, if you look at the local testing, all the things that comes with that, all the good things, like being able to run your code locally, being able to use breakpoints to step to the code, and also not having to wait for whole deployment to figure it out. I've got like a typo in one line. That's great, but then local testing typically is running your code against the mocks, which is asking, does my code do what I expect it to do based on some assumptions I've made about the things that I'm mocking? Whereas with testing against the remote services, the real thing is asking, does this thing actually work? And the difference sometimes is that, well, my assumptions about the thing I'm mocking, the behavior of that thing, can be wrong, right? I've seen so many tests that's all green. You deploy, the first time it runs, boom, it doesn't work because I've got one typo in, say, a DynamoDB query syntax, which that's the interaction with DynamoDB that I've mocked out. So my test is testing everything else, but not that one part of integration, the one thing that can go wrong, and when I'm running the real thing, in the real environment, it blew up. So with local testing, you're not going to have the full coverage in terms of all the different other things that may come into play as well, such as IAM permissions and other things like that, and they're prone to false positives. So I can't really draw really good confidence from running the local tests. And I want to stress this again, that serverless is more than just Lambda. It's more than just your code. There's a lot of things that are outside of your code that's part of the application nowadays. A lot of the security settings, a lot of the maybe integrations and how data goes from one place to another. That's all outside of your code. And your job is to make sure all of it works. You care about your application working, not just your code working. And so that's where oftentimes you talk to AWS people, they will tell you to do remote testing instead. So you execute all of your tests against the resources you have created in the cloud. So you are going to test them in the real environment. And so you can get better confidence that what you have actually works. But the problem is, well, you have to wait for deployments. Every time you make a small change, it could be adding a comma to a line 562 or whatever, you have to wait for 10, well, maybe not 10, but maybe 1 or 2 minutes just for that deployment to happen, and then run your test. So the feedback loop is very slow. And that's where the idea of a remote code testing comes in, that you get some of the best parts of both local testing and remote testing, so that you are executing your code locally against the real AWS services, so you can still use breakpoints and the debuggers and whatnot, and you can still find out integration problem between, say, your Lambda function code and, say, something that you're talking to in DynamoDB. But this is still just looking at what happens in your Lambda function and how your Lambda function integrates with other services that you're using. It doesn't look at things that's happening ahead of it. Things like integration between API gateway and your Lambda function. If you're using Terraform, am I missing a Lambda permission object? And if I'm using EventBridge to call my Lambda function, maybe I've got a typo in my rule, in my event rule, so that when the event is received, it doesn't trigger my function because I've got that typo. So there's still a lot of things that can go wrong. So even if I'm testing my Lambda functions with this remote code test, I still want to have some way to test the whole application. So I will still have a body of end-to-end tests. In terms of the pros, this approach is, again, just based on how you structure and test your code. So it can be applied to any language, any framework you want to use, but it also still can't test those managed integrations. And so if I was to look at, say, an API gateway API, rapid REST API, and depending on what feature I'm using with API gateway, I can write the end-to-end test to cover some of the things that I'm using Lambda for. I can use remote code test to test my functions integration with other services. Then in core domain logic, I can use a unit test for those. And then other things that I'm dedicating to API gateway, like talking to DynamoDB directly, I can test those using end-to-end tests. And similarly, if I'm using authentication, using Cognito, AWS IAM, or API key, I can test them. I can cover those with my end-to-end tests. But if I'm using a Lambda authorizer, that's just a Lambda function. So again, I can write unit tests, remote code tests, and test the logic. So to give you an idea how this might look in the real world, so I'm just going to quickly switch over to give you guys a quick demo so you can kind of visualize better what that looks like. Just give me a sec to switch to mirroring so I can show you. OK, so I prepared a repo here. Is this visible to the folks at the back? I can't really see you. Just shout yes or no. No? OK, all right. How about this? All right, cool. All right, cool. OK, so this project is an API project I've created to kind of showcase the idea. It's using the server framework, and so I've got an API with some endpoints. This one is API gateway calling DynamoDB directly, and I've got some VTL template to transform the data as it comes back from DynamoDB into regular JSON. And if data is not found in DynamoDB, then I return 404 instead of a no. But more importantly, I've got a bunch of Lambda functions here to handle different routes. So one route is handling a post endpoint using AWS IAM. That's a schema file that I'm dedicating schema validation to API gateway. And this schema file is basically saying that whatever comes in the post body needs to have a name string. So I want to show you that there are different capabilities that I'm using from API gateway versus things that I'm going to implement in my code. So I'm just going to show you this add restaurant function. It's just very, very basic. I'm not using TypeScript. I'm using the JS doc, so that I got some IntelliSense support to say, when I say event dot, I can find out what's in the event body, event payload. In this case, I can say, OK, this function is just writing whatever comes in the post body into a DynamoDB table and then returns a 200. So if I want to say, OK, write a test for this, I can go to the test folder I've got here. How can I collapse this? OK, in the test folder, I've got a bunch of test cases. And for things like event schema validation for the post endpoint, because I've delegated to API gateway, I can't test it locally. So I've got a test case that is going to be run as part of my end-to-end test. And what it's going to do is essentially make it easy for me to write the test. I think this is a very important part that people often overlook, is you want to make your test code really easy to read. So I'm saying that when we invoke this add restaurant function remotely, and so this helper just basically looks at the environment variable that I've set up called the test mode, and if it's end-to-end, it's going to call this endpoint remotely by calling post restaurant's endpoint. And so if I was to open up and look at the package.json, I've got two test cases set up here, one to run the end-to-end test, one to run what I call the remote code or integration test. And I'm using this jest to run the test cases based on the grouping that I've set up in the test case, in my test case here. Nope, that's the wrong one. So the schema test here. And I'm expecting that if the schema is missing the name, it's going to return a 400. But if it's got a name, but the name is null, it's also going to return 400 as well. But I'm missing the successful 200 case. And also got a test case to just test the endpoint, the post endpoint, with a body that's got a length of 16 characters. So in this case, this is actually something I want to test as I'm developing the feature. But once I'm deploying the Lambda function, I still want to run end-to-end test for it. So I've got this little trick whereby I'm running this as both integration and end-to-end test. And in the when step, when we invoke add restaurant, I've got this toggle to say, depending on what's in the environment variable, I'm going to either run the function locally or I'm going to execute the function, the endpoint remotely. So I'm going to show you that if I was to just use a JavaScript debug terminal, I can actually put a breakpoint in my function code when I run those remote code tests. And so if I was to say put a breakpoint here, I can just say npm run test int. And this is inside a JavaScript debug terminal. And so when the test runs, it's going to execute that add restaurant function, and it's going to hit my breakpoint. And so in that case, imagine if I was to make a mistake and return no instead, I'm able to say run the test, figure out there's a problem, and quickly iterate and change it. So again, if I run the same test again, it's going to say that one of the test cases has failed. It's going to take a few seconds to run. OK, there you go. So it's going to catch the problem that, OK, where's the error? OK, the error is here. So it's going to say, OK, we're expecting something to be not null in the body that comes back from the HTTP request. And so, OK, I'm going to fix this, and I'm going to go back to what it was before. And now I can quickly, again, just run the test again. And it's going to fix it. And once I'm happy that my code is working, I still want to cover all the other things that happens around my application that's not inside my code. So I can, once I've done that, I will run serverless deploy, for example. And I then can run the test for end-to-end tests. So this will actually call the endpoint that's been deployed in AWS, and so I'm able to exercise other things as part of our application, but outside of my code. So as you can see, when you're running those end-to-end tests, it takes longer. So you typically have fewer end-to-end tests and more integration or remote code tests that allows you to exercise your business logic and everything else without having to wait for long deployment. So by combining different kind of tests, I'm able to, both get a fast local feedback loop as I'm working on my code, but still get that confidence that everything in my application is working by covering different parts of them. But the one downside of this approach is that, well, when you're running your code locally, my function is talking to the real DynamoDB table to write data to the table. So we do need those AWS resources to be created in the first place. And so this is where the use of ephemeral environment comes in, where I can create temporary environment just for, say, working on a feature. So that way, everyone in the team can work on something different at the same time without fighting over who has got access to the dev environment, for instance. We're going to talk about that in a minute, but for now, just know that there are multiple ways you can get the local development experience when it comes to working with Lambda functions and serverless architectures in general, depending on how much of your application is in your code versus there are just configuration of AWS services that are doing those managed integrations between different services. So the next thing I want to cover is in terms of deployment. So a lot of the time, the problems I've seen here are actually self-inflicted. And I've seen people try to make deployments maybe more complicated than it really needs to be. And when it comes to deployments, I really want to just keep things simple as much as I possibly can. And the Lambda is 10 years old now. When it first started, everything was a lot simpler. But nowadays, there's such a lot of choices you have to make. Because Lambda has got Lambda layers, it's got support for container images. You don't just use zip files. You can actually just say, here's all my code in a container image, and have Lambda load the content for the function from the container image instead. There's also different custom runtimes you can create yourself. If you want to use, say, C++ or Haskell or Erlang with Lambda, you have to do that through a custom runtime. There's also different concurrency models. You can use provision concurrency. If you know there's always going to be some baseline amount of traffic, you want to minimize cold start, and you can use provision concurrency for that. So there's actually a lot of different things you can do. I think those are great to solve specific problems, but it's not something that everybody should be using. A lot of the time, you can do away without them. And Lambda layer is a particular problem that I've come across a lot, because this is something that the AWS Data Advocacy team have often promoted, that you should use Lambda layers to distribute your shared code between different Lambda functions, except it creates a lot more problems than it actually solves. For starters, unlike package managers like NPM, there's no semantic versioning. Your Lambda layers are going to version from 1, 2, 3, 4, 5. How can you communicate which one's breaking change? Which one is a patch? Which one is just adding new stuff? And also, well, if you got loads of security scanning tools that scans your code, well, again, Lambda layers to deploy, you take your code, you just upload to the AWS. Your security tools that doesn't really see those when you try to deploy applications through the CI/CD pipeline. And you're also limited to just 5 Lambda layers per Lambda function as well. So how do you organize your shared code into just 5 layers so that you don't run out of space? And a lot of people think that, OK, we use Lambda layers so that we are bypassing the 250 meg package size you get with Lambda. Well, unfortunately, it doesn't work because the 250 meg size is a limit for everything, not just what's in your zip file, but also what's in your Lambda layers as well. And they also make it harder for you to test your code because if all of your shared code dependencies for your application is uploaded to AWS, then you need tooling support to pull them down to your repo as you're testing that project locally with, say, remote code testing and whatnot. They also don't really work for static languages that need to compile to, say, a shared or one jar, for example. They're kind of designed for Python and trying to promote it for everybody. And it just takes longer and more work to publish a new version of your application, of your shared code to NPM than, to Lambda layers than to just do it through a boring NPM package. And also, if you're using bundling and things like that to remove the size of your Lambda functions, again, that kind of breaks the whole mechanism. So lots of reasons not to use Lambda layers to share the code between different Lambda functions. With most of the framework, if you've got, say, 2 Lambda functions in the same application, the same API, for instance, you can just have a shared library in the folder and reference that. Most tools like Server Framework, SAM, or CDK all handles that for you. Especially if you're using bundling, they can reference that shared code, take what you use from that, and then they'll shake that into a smaller file. If you're talking about shared code between different Lambda functions across different service domains, again, well, you can just publish those shared code to NPM package, and your other functions that are serving different workloads can just reference them through NPM as part of your development process. Another thing is I mentioned Lambda can use zip files as well as container images. I think unless you really need container images because you are running against a 250 meg size limit and container images can go up to 10 gig, then you should still use the zip files if you can, because when you're using zip files, you're using managed runtimes that are provided by AWS, which means the security of the runtime itself is no longer your responsibility. Now, if you're using container images, it's your job to make sure that whatever's included in that container image is secure, is patched, and updated regularly. And so, again, for deployments, just pretty much nowadays, I'm still doing deployments with Lambda the same way I was doing that 5-6 years ago, even though there's all these new things that's come out. Those things are useful for specific problems. Unless you have those problems, just stick to the boring zip file, managed runtimes, and not using Lambda layers to share code. And so the last thing I want to touch on is just about how to then map your deployments and everything to your application environment. So one question that comes up is, how many AWS accounts do I need? Typically, I advise you should have at least 1 AWS account per environment, well, per stage, per team as a minimum. That way, you've got an application, you've got 1 account for dev, 1 account for test, 1 account for production. That way, if there's some compromise, someone managed to steal credentials for your dev account because someone put out the credentials into a source code and got leaked, at least the attacker can't get access to your production data. In this case, I've got my main environments, dev, test, staging, production. They're all separate AWS accounts. But then I also want to make sure that if I've got, say, different teams that got their own set of accounts, and sometimes if you've got the workloads that are particularly, say, business critical, or it has a really high throughput compared to other services, you also want to have a different set of accounts for those services to isolate them from other services so that you don't have one service using up all the available resources that other services gets throttled and things like that. And then finally, I mentioned earlier, ephemeral environments or temporary environments. So this would be a case of, say, I'm starting working on a feature. I run a command to deploy my application to a new environment called dev my feature. So this is going to create an entire set of resources for API, for Lambda functions, for DB tables and whatnot. And so I'm able to just make my changes, iterate on the code, run local remote code tests against that temporary environment, make sure everything's working. I create my commit, my PR, and then the CI/CD pipeline is going to run all my tests. And when that happens, OK, I know my job is done. The feature is complete. I can run serverless remove or CDK destroy or what have you to delete the environment. And multiple people in the team can do this at the same time, so everyone can work on different features in their own environment without stepping on each other's toes. And so, this just makes life a lot easier when it comes to managing those environments and your development workflow. And you can isolate your environment for testing as well, so that if you've got tests that potentially interfere with other tests, you can now say, okay, we're not going to pollute our dev environment or staging environment with all this junk data we created as part of our test. All of those are going to be created in the ephemeral environments that are deleted right after we finish the branch for the feature, for example. So we can keep those shared environments like dev, test, staging nice and clean as much as possible. And also, when you're using serverless components, remember I talked about serverless being scaled to 0 and paying for usage. You can have as many of these environments as you need without paying anything extra because you're not paying for uptime. If you have tests that executes API 100 times, it doesn't matter which is one environment versus another, you're paying for the 100 requests. So when you're using serverless components, there's no extra cost for that. What if I've got my Lambda functions talking to RDS instead? I don't want to run 10 RDS clusters. So for that, I've got a different way to kind of work around that. Essentially, you've got your cluster, but you run different databases inside the same cluster, one for every one of these temporary environments. You can also use the temporary environments for your CI/CD pipeline as well. So actually execute all of these tests and creating all this test data. Do that against a temporary environment that lives for the duration of a CI/CD pipeline run. So when it's done, you delete it. You can just name the environment, CI, whatever, so that you can have, again, as many of these as you need. But an environment doesn't equal AWS account. You don't want to create all these accounts for that, right? So typically what I do is I've got my account for each of the main environments, and then for the dev environment where the developers work, I will have as many of those temporary environments as I need. That I've got one environment for myself, I've got environments for different features I'm working on. Those are all created against the dev account, so that an environment may be represented as the cloud permission stack that captures the API, gateway, Lambda function, DynamoDB table, and whatnot. But it may also be bigger than a stack. If you're using CDK, you may be breaking your resource into different stacks. So an environment is captured and represented by a CDK application. Or maybe some combination of other things. Could be SSM parameters, could be shared RDS cluster, and so on and so forth. But ultimately, you may have to solve this problem of how can I make sure that when I've got different environments running the same account, I don't run into problems where someone's already got a Lambda function called X, Y, and Z. So in that case, simple rules to follow is don't explicitly name things unless you have to, because CloudFormation does that for you and adds a random suffix at the end. And also make sure that where you do have the name things, you include the name of the environment as part of the resource name. So that way, you can create as many of these environments in the same account without running into issues with name clashes and whatnot. And this also works really well with remote code testing because you need an environment with your DynamoDB tables and other things for your code to talk to as you run those remote code tests. So again, 3 things that you want to really look at, and these are 3 things that is going to help you have a nicer development experience when it comes to working with serverless technologies. And as far as the local development goes with, say, Lambda functions, here's the 5 different ways you can do this. And I hope I've given you some ideas on how to look at your development workflow when it comes to serverless and how to make that, how to make your life easier as well. And if you want to find me on the internet, there's a QR code there with all my links to my blog, newsletter, workshops, and what have you. And if you've got any questions, I'm happy to take them as well in the last couple of minutes. Otherwise, thank you very much. I'm going to be around later if you want to catch me in person and ask me questions. Okay, thank you.